Hey, so we'll get started. So welcome once again. Thank you for joining us. We are going to get started with the webinar today, which is part of our Citrix Ready technical webinar series. I am Sagnik Datta and I'll be your host. I work for the Citrix Ready as the technical marketing lead and support desktop ecosystem partners with their product integrations and go-to-marketing activities with Citrix. Today we have invited with our partner NVIDIA to showcase some of what their latest offering stands today with the Citrix solution stack. We'll be talking about Digital Workspace. The topic is core to our company's value proposition, transforming digital workspace. We truly believe that the business productivity improves when enabling your digital workforce. Our main speaker is Jared Cowart. He's a senior technical product manager at NVIDIA GRID. He's a very knowledgeable man, and not just GRID, but ecosystem technologies as well surrounding GRID, especially Citrix XenServer and XenDesktop. Jared, could you take me to the next slide, please?
Should be there.
Yeah, the Citrix Ready, to give you a short introduction, it's an end-to-end technology program that we help you make a better purchase decision when looking out for third-party products that work with Citrix. Citrix Ready Marketplace, that's the link over there, citrix.com/ready. And if you are a partner who are willing to join us, showcase your product integrations with Citrix, that's the partner page and the second link that you have there. So I'll be handing over now to Jared to get the ball rolling. But before I do that, I just wanted to bring up a few housekeeping items. For questions that you have during the webinar, please type them down in the question panel that's available on your right-hand side. We'll be taking them as we go and also at the end of the Q&A session that comes at the end. All right, now, without further ado, I'll roll over the dice to Jared. Jared, I welcome you to the technical webinar series, and let me now hand it over to you.
Yeah, thank you so much. I appreciate the opportunity to be on the Citrix Ready series. Something that NVIDIA has been a part of for about 5 years, and it's been just a fantastic experience. I would encourage other partners to make sure that you're a part of this program. It's been wonderful for us, and we really appreciate the opportunity to be here today. So before I get going, I wanted to really quick just lay out kind of what NVIDIA is. Kind of companies are always evolving, changing themselves. And if you look at NVIDIA nowadays, we classify ourselves really as the AI computing company. Maybe in the past, we were the graphics card company and focused around, some of you might know us from maybe your gaming machines or your professional workstations. You know, that's a piece of what we do, and we still do that really well, but we've now evolved into artificial intelligence and machine learning, GPU computing. Literally, we've discovered ways where we can use these graphics cards now to do everyday computing type workloads for, you know, making some of the biggest changes that humanity has seen, which is just an honor to be a part of in this company. Today, though, we're going to really focus on this computer graphics, which a lot of you might know us as, but I wanted to give you kind of an idea of where we're evolving into. By no means are we leaving our computer graphics heritage behind. Matter of fact, we're doing a lot of wonderful things, you know, like NVIDIA GRID. NVIDIA GRID is a software team within NVIDIA, and what we do is we focus on a couple of different solutions. We focus on a solution for business PC users and workstation users in a virtualized type environment. This would provide those graphics for the applications that maybe you see above there. On the left-hand side of the screen, we're dealing with our office productivity applications, our browsers, media engines, Photoshop, and then we go all the way on the right-hand side to our Dassault type applications, ArcGIS, Petrel, and such. So this platform that we've now developed gives us the ability to handle and address these different types of users in a XenDesktop or a XenApp type deployment. So what's going on and why is graphics needed in virtualization? Maybe you ask yourself, I've been doing virtual desktops for quite some time, why do I need graphics now? Well, with the advent of 2016 and Windows 10, users still require that snappy experience. They want the experience that they can get on their maybe high schooler's netbook that you purchased for them. A lot more components within our deployment and within our day-to-day lives rely on coding and decoding of graphical content. This might be video, this might be 3D images, but a lot of that is required. CPUs can sometimes do some of this stuff, but it's not designed for that, and so it can be inefficient. The other challenges here is as user density gets bottlenecked when we have to use those CPUs to provide maybe snappy experiences entering, encoding, and decoding, so it can impact the overall scalability of our deployment. So that's why GRID was created, a solution that gives us the ability to provide graphical user functionality in a virtual desktop deployment. So let's look at the overall NVIDIA solution real quick. Again, just an overview, and then we'll jump into the management aspect of this. But for those of you who don't know what NVIDIA, the GRID solution is nowadays, I just wanted to quickly overview this. So the platform, the solution that we've developed, rides on top of NVIDIA's Tesla data center GPUs. So we've actually had data center-based GPUs for quite some time. These are the same GPUs that we use for doing machine learning, doing high-performance computing. These are optimized for server-type deployments. Typically, they don't have a fan. Typically, they're certified with specific hardware platforms. And you can see here, we have a broad ecosystem of vendors that now have them, and clouds that run these data center GPUs. NVIDIA GRID, which we're going to focus on here today, is the software stack. And what this enables us is to carve up those GPUs, present virtual instances of those to virtual machines and or XenApp, and then also provide support and compatibility with miscellaneous ISV application vendors. And then on top of that, NVIDIA GRID has support, it has updates, maintenance, so we provide a couple of major feature enhancements a year, and then around 4 maintenance enhancements a year that come with the solution that we work real hard on. But now you've got the ability to phone into NVIDIA. We can work with the different vendors that are involved in your deployment to ensure that that graphical experience is as good as it should be. So from a hardware perspective, let's just really quick talk about the physical GPUs. This is the Tesla GPUs. The current lineup is M10, an M6, and an M60. I like to just classify them very simply as the M10 is a user density optimized board. So if you're looking for max density, you're not looking for huge amounts of performance, the M10 is the product that you should be looking at. If you're dealing with blades, it's going to be the M6. And if you're looking for the most performance, maybe density doesn't matter, it's all about that user experience, you've got high-end use cases, then the M60 would be the platform for you. So pretty simple. Really easy lineup, makes it real simple to choose what type of deployment. And we have many customers that mix and match these as well. Maybe they'll do an M10 for the knowledge task type users in their organization, then they'll do an M60 for other users that maybe are higher end graphical users. So let's talk about kind of just really quick the bullet points of the GRID solution, kind of what we call our platform. It's built on our enterprise tried, tested, true, tested GPUs. It's open and scalable. Open means things that I'm going to show you towards the end that Citrix and a lot of our ISV partners have taken advantage of. But there's open SDKs and things that people can leverage to expand solutions. Application performance and reliability. What this means is that we work with those ISVs. So if you look at the list of ISVs, that's just a short list. We have hundreds of ISVs that we have teams that work with that ensure that the drivers are optimized for the solution. And from a support perspective, if you run into challenges, we can broker relationships and work on making sure that is down. Scalability and deterministic quality of service, so making sure that when you carve up a GPU, that users are having the experience that you would expect. The big focus for today is this comprehensive insight and monitoring. What we've really focused on is enabling all aspects of the experience relating to GPUs to be monitored and be able to pull that data back in to make intelligent decisions, and we'll go into that a lot more in detail here shortly. So optimized management and just a significant amount of broad industry support. So this is a short list of the ISV vendors that are supported. If you go out to our webpage, we have a longer list of all the different server platforms and how many GPUs and what's going on, and I think you'll be surprised at how large that is and how much it's grown to nowadays. So from a software perspective, a lot of people questioned when we moved to this software model. But what I really want to kind of focus on with this is that we're adding value over time. So it's about first was kind of density, then it was performance, then it was management, and getting into more graphic enhancement capabilities. if you look here, here's just an example of kind of a couple of years worth of releases. First when we went to Grid 2, where we implemented the software model, we increased scalability, added Linux, and doubled the performance. So kind of some neat things. Then we migrated into enabling Virtual Apps Edition for XenApp, more 4K support, and then with Grid 4, we start adding Vulkan support and protocol acceleration. With that protocol acceleration, I'm going to focus on a little bit of this later on, so I'll briefly talk about this. But this is using the GPUs to actually encode the HDX 3D Pro protocol. So we now can leverage that GPU that's got untapped resources on it, what we call NVINC, or an NVIDIA encoder, and now HDX 3D Pro can leverage that. So we added that support with the solution as well. And that's the kind of CPU offloading capabilities there. We also added in monitoring. We got monitoring with both XenServers and desktop. We got it with VMware, which gives you, who maybe are running a Xen desktop environment on VMware, the ability to monitor that as well. And then we also implemented the M10 kind of the density optimized platform. And can't talk about it now, but lots more to come shortly in regards to more features that I think we could stack all of these on top of each other, and they wouldn't remotely equal what's coming with the next versions of the product. So lots of more stuff to have, lots more innovation to come. So how does this stuff work? I'm going to go through this really quick. So we've got to have on the right-hand side, we got Xen Desktop. It can run on vSphere and or XenServer. In the bottom platform here, we've got our server with an NVIDIA GPU. Within that GPU, we've got some different components. So we've got 3D engine, we've got a copy engine, we've got NVIDIA encoder and NVIDIA decoder. And then the NVIDIA code kind of overall solution here. We then in turn can chop up that GPU, pass those into a virtual machine. Within the hypervisor, we have a GPU manager, which helps present the management data that we'll talk about here shortly. And then we actually are running our NVIDIA graphics drivers in either the virtual PC or the virtual workstation. In the workstation, it's a straight-up Quadro driver. If you're familiar with our Quadro product line, this is the most heavily deployed professional graphics card in the industry, and that running the same driver, which gives us the same level of support. Over on the left-hand side, you see here we've got our NVSMI and NVML. These are our management libraries, and these are open, which give Citrix, VMware, and a laundry list of other Lakeside, Liquidware, Goliath, all these other vendors, the ability now to pull that data into their reporting mechanisms so we can better manage and deploy our projects. So almost everything in the deployment is shared. A couple things are dedicated. If you look here on the right-hand side of this, our frame buffer is dedicated. So we dedicate frame buffer to each virtual machine. And then we share and time slice the access to the compute, the encode, decode, and copy engine. So what time slicing gives us the ability to do is to give each virtual machine or user full access to that entire, in modern capabilities, 2,000 CUDA cores during their exclusive access to that entire engine. That's kind of how that plays out. So let's jump here into kind of what hopefully you came here today to deal with, and that's really talking about the management, monitoring, and some neat innovations that we've dealt with in regards to this. But without monitoring and management, it really is a challenge to understand what's going on with your deployment. You have a user that's hitting the GPU really hard. How do we level that out? Are they using the right profiles? Do we have more space where we could scale more? It gives us a lot of capabilities. So if you look here, GPU visibility is really critical in every phase of our project. So as we're designing or assess, design, deploy, pilot our solution here, really, really critical. As we get into deploying, it's really important for help desk, IT administrators here to be able to monitor it while it's being deployed to make sure that things are done correctly in regards to right GPU sizes that we've deployed. As we get into, once the project's deployed, having the help desk be able to monitor and see if there is challenges and or issues within that. So if we look at this kind of as a lifestyle approach to managing our user environment here, it's really about understanding graphics resource dependencies, the right size, day one virtual infrastructure that's scaled correctly. selecting the right GPU profile for the right users. We have options. We don't just carve it up indiscriminately. We have the ability to do different size GPUs for each user. And we want to make sure that we're using the right one for those, and this gives us that ability. In production here, we want to proactively address brewing user experience issues instead of reacting to them, and this now gives us that ability. We want to plan for upgrades based on real-time analytics. Is our GPU usage going up? Did we deploy a new application that's very GPU heavy and now creating challenges with our deployment around that user experience? And then we also want the ability, based on that metrics and that data, to be able to fine-tune the user environment, and this all gives us that ability. From a help desk here, we want to be able to isolate where a challenge or a fault might have happened. We want to be able to avoid wonderful circular finger pointing, and ultimately just accelerate our issues is really the challenge here. So let's talk about what we can do. So we have created this NVML, this different kind of SDKs that people can tap into to monitor two core components. The first one is our host. So within the host, or the XenServer or VMware host, we now have the ability to pull our clocks, our temperature, our power utilization, and pass that into any reporting tool. Or any reporting tool can grab this data. And we can see the overall GPUs utilization, physical GPUs. We can also understand what VGPUs are capable of running within that environment, are created already and running, and are supported within the environment. So a lot of different capabilities there. The big one for me here is understanding how many displays and resolution and frame buffer allocations and license status, how much has that been leveraged. Probably even bigger gets into understanding, and I'll explain this in a minute here, it's really understanding encode decode utilization. We want to see that encoder being leveraged. We want to see it being used. And having this capability gives us that ability to know how much it's being used within our deployment. And I think you'll understand more here in a minute as we dive into that, but it's pretty significant of why we want to see that encoder used. In an upcoming release, I got permission to talk a little bit about this, but we are getting into understanding more and more about the per application. So getting a little bit more granular and understanding per application 3D encode and decode utilization. So this is just on the host itself, the physical card. Now, the challenge we've had in the past is it was very difficult to get into monitoring the virtual machine or the guest. And when the guest, if we were initially just monitoring the same type of host data, it impacted, or what another user was doing could impact the results for that user's virtual GPU. So now we've isolated this, and we're reporting specifically on each individual GPU, 3D utilization, encoder, decoder, frame buffer usage, and then we're getting granular in regards to per application 3D encode and decode. This is going to be great because this is something that can give you the ability to understand which applications within your deployment might be chewing a lot of GPU. Maybe you see a lot of YouTube traffic happening there, and realize that maybe people aren't being as productive as they need to be. But you've got a lot of capabilities in the future around that capability. So really, this is just a fantastic solution in regards to its standard GPU tools. So if you look at NVSMI, this actually allows you to leverage like perfmon. So within your virtual machine, you can actually go right into perfmon and pull in the NVSMI data and see it by yourself without purchasing any third-party tools. So it's seamless to any existing IT tools that you might have today. So if you've got existing monitoring tools, you could actually add these NVSMI into your metrics and now start watching that data. Now, that doesn't mean we didn't stop there. We actually worked with people like Citrix, Lakeside, EG Innovations, ControlUp, Liquidware, and many others to also enable them to build this monitoring within their platforms as well. So we've got a growing ecosystem of partners that are now monitoring that data, which is quite significant. And back to that kind of open platform, this is an open SDK that you can actually download yourself. And it brings, GPU insights into your own tools if you want to. So we've got a handful of customers that have their own kind of homegrown monitoring tools that are taking advantage of the SDK to pull this data into their solutions as well. But overall, really great capabilities there. So let's talk a little bit about Citrix specifically. A lot of people don't realize that XenServer can do real-time monitoring of about anything. And so we worked hard with Citrix to make sure that within their platform, and if you're a XenServer and NVIDIA customer today, I encourage you to jump into XenServer and take a look. You may have not known that these were there. But we've got real-time GPU, memory, temperature, power usage, all of this different type of data already existing within this tool. So it gives you the ability to monitor this today, which is pretty cool. Now, at Synergy, we had a really fantastic show. We did some really neat interviews with the Ready team that are on YouTube today that I encourage you to find. And some of the things we highlighted was the grid teams, or the directors team implementation into Director. So what they've done within Director now is you have the ability to go in and monitor GPU utilization, memory utilization, decode, and encode on a real-time basis. So on a backstory of this, to kind of talk about why the Ready team is so fantastic, is this went from idea to deployed in about 2.5 months. So really neat to see the two teams working together around the Citrix Ready Alliance to make this happen so fast. But a lot of customers already using this. This comes by default. It's in production with XenDesktop 7.1.4. And if you are an NVIDIA customer, we now have the ability to monitor that right within Director, real-time profiling, help with troubleshooting, all different kinds of neat things there. So the other thing that we highlighted at Synergy, which was a huge hit, the top requested feature over the last 4.5 years, was XenMotion. So we actually showed XenMotion. Obviously, we know why this would be useful. Really about server maintenance, being able to relocate virtual machines around to do any server maintenance, load balancing, our users across that, and then ultimately just maximize our investments here. But if you're not familiar with Motion, I think you should be, but in this scenario, I'll just really quick go over this. We've got our 3 servers, server ABC, got our NVIDIA M60 in it, we've got all of our virtual machines, and basically being able to migrate that machine live from A to B is what it's all about. So this is a huge feature that now we demoed. So it wasn't, just to caveat this so everybody knows we don't have some confusion, because I'm sure it'll be in a comment or a question. We showed was what we're working with Citrix engineering on. So this was an engineering demo, and that's where it ended there. Now, what we announced is essentially here that we're targeting for a Q3 early access program. And you can see there's a link that gives you the ability to sign up for that if you're an NVIDIA customer and it's something that you wanted to participate in. But sometime within the next couple of months, there'll be an early access program that we'd love to have any of you NVIDIA customers a part of, that should help us, help you and us make the solution ever so much better. So I was kind of putting this deck together. I really thought one of the really important pieces is kind of understanding performance around Windows 10. I'm hearing a lot more customers starting to plan and start POCs and pilots and even production rollouts around Windows 10. So I wanted to show you some of the things that I deal with on a day-to-day, that our teams deal with at NVIDIA on a day-to-day, and hopefully some of this stuff will help you in regards to kind of monitoring measurements. Now, I couldn't have gotten all this data without that neat stuff that I showed you before. And I'm going to show you some additional tools. Some of them I could maybe give you links to. Some of them are kind of internal in-house. But one of the things we did is we went and initially did kind of a, think of it as a Coke, Pepsi blind taste test. So we brought in a whole bunch of temps, and we didn't tell them if it was a virtual machine with a GPU or without a GPU, and we gave them scripts of things that they needed to go through, everything from searching mail to PowerPoint editing, and there was kind of videos of what they needed to do. And this was the kind of blind results, as you can see here. In a nutshell, the blind results came back at 34% increase in Windows 10 user experience with Grid versus Windows 10 without Grid and just the GPU. So this is the legitimate data that we ran on blind users and the overall feedback there. So we took this even further. Now, this comes from some of our game heritage. Our gaming heritage is like no other. We love the gamer. NVIDIA actually encourages its employees to get out there and spend time playing games. That's not a problem. And with that, we have a solution here. You can see, hopefully my cursor is showing up. But you can see here we have a special mouse, and on this mouse there's actually something hooked to it that measures when we click the button. And over on the screen, you can see I have another measurement into this oscilloscope here. I've got another measurement here. And the idea here is I want to measure when I click to when this movement actually occurs. So when does it actually click? And so we call this click to photon, and we're measuring latency. So let's talk about these numbers because they may blow your mind. So a couple of things. This was done completely on a local area network, so less than 1 millisecond network latency. So right out of the gate, the latency between clicking the mouse and showing up on the screen is 65 milliseconds. So that's as best as we're going to get, 65 milliseconds with an integrated GPU, bare metal, physical machine, no virtualization whatsoever. So this is literally as fast as you're going to get in regards to that latency. When we start remote connecting to this, and in this scenario, we're using encoding just done with no GPU at all, 220 millisecond latency. So that's when that user actually gets that responsiveness. With remote with an M10-1B, we drop that down to 160. And you can kind of see the numbers. The key I want you to focus on here is over on the very far right. Now, this is that advent in Grid 4 where we started leveraging NVINC to work with HDX 3D Pro. Now, HDX 3D Pro now can use the GPU to do the encoding. We don't have to route down to the CPU to do the encoding and then back to the network bus and back out. We can now go straight from what should be on the screen, do the encoding, and out to the user. As you can see here, we're down to 110 milliseconds here of overall latency. So from 65 on a local physical machine to 110, and 150 milliseconds, by the way, is the benchmark set by our GeForce Now product. So we have a GeForce Now product. You may not know about it, but it's essentially Netflix for games. You can, with Windows and Mac and a Shield TV, you can stream your AAA titles right down to your computer, leveraging our technology. And 150 milliseconds was our threshold that we set that we wanted to achieve. And you can see here that we're significantly achieving that with this type of a number. So important data to know because this really comes into measuring user experience. If we had to pick up a way to measure user experience, this is how we do it. When that number goes up, the users get frustrated. When that number stays around the 65 to 110 to 150, it's acceptable to users, and they really can't tell too much of a difference. But neat numbers, but it shows the significance of the implementation of NV encoding with the HDX 3D Pro that we've worked on together. So here's one of the reasons why, just to kind of show you. On the left is HDX 3D Pro CPU encoding. On the right is HDX 3D Pro with NVINC encoding. For those of you who don't know what this tool is, this is a GPU tool written by a solution architect at NVIDIA named Jeremy Main. It's free. It's called the GPU Profiler. You can download it, play with it, but it gives you the ability to monitor all this real time. Again, he's just using the SDK. He wrote it because it was needed. So it's a free tool out there. But you can see the difference here in the amount, the red line being the CPU utilization, but a significant reduction in overall CPU utilization when you're using that encoder. So here's the roundup, and this is done by our performance engineering lab. 34% increase in user experience, 140 milliseconds in reduced latency, and a 42% CPU offload to the host. So pretty significant data here by just adding the GPU into your deployment. Imagine what you can get from scalability. You may actually be able to get better scalability, better overall experience. So a couple more slides, and we'll wrap this up and get into some Q&A, because I see some questions are coming in here. But one of the things that was highlighted actually last week, we were at a Citrix event last week in Finland, and one of those events is going on with partners in Bangkok today and this week. Is one of the things that's being announced is customers can start leveraging the NVIDIA Tri-Grid experience with the Citrix Cloud. If you actually go out to NVIDIA.com/Tri-Grid, you now have the ability to get 24-hour access to the Citrix Demo Cloud to evaluate the Citrix solution with NVIDIA GPUs. It's a really cool solution that you guys can actually try it before you buy it. You can touch it, you can feel it, but really cool capabilities that you can leverage. So I encourage you all to look at nvidia.com/trygrid. I would give you the ability to take a look at this today if you wanted to. So that's what we had today. Hopefully we saved enough time for some Q&A. So we had about 35 minutes or so of content, and I think we got some questions teeing up. So I know we got some people watching questions. Maybe we can fire those off.
Hey, thank you so much, Jared. I think we can move, then let's move to the Q&A session. Very quickly now, so one question that was being asked is about the NVIDIA M10 profile. So can it be configured to use 256 MB instead of 512 MB? The M60 is capable per user.
No, 512 is the minimum profile size, and there's some reasons behind it. We've done quite a bit of testing, and I have a slide I could maybe find out. So basically it comes down to a couple of things. When we're leveraging the GPU, the resolution size of the end user matters. The answer to your question is if you were running, 800 by 600 resolution, yeah, we might be able to pull something like that off, but it wouldn't be a wise decision for everybody across the board. So we kind of set a minimum of 512 being the solution that makes the most sense for users from an experience perspective. So 512 is the minimum profile. And you can't run into the 256 profile. It's just not enough compute power, and it's not enough frame buffer to handle resolution sizes of modern capabilities, or let alone dual monitor capabilities. When we start getting into dual monitor and 4K resolution, those frame buffer numbers go really high, and we need to make sure that frame buffer is there for users.
Cool. Another question is on the NVIDIA for VDA. We are looking to get Tesla M10 cards for our POC. However, we are running into 3 display monitors, HD display monitors as standard offering for our people. How do we properly size the grid profile? So the resolution they're talking about is 3 into 1920 by 1080.
So it's three distinct monitors per session is what we're dealing with.
Yeah.
So we probably should talk offline because I need to know the resolution size and some other things. But we have some guides around this, and we've also one of the things that not a lot of people know about NVIDIA that I would encourage you guys all to kind of know about is that we have a sales team, we have solution architects across the globe. So what that means is that they're not commission-based guys. They're there to just architect the solution correctly and make sure that it lives up to our standards. Engage them. If you go to the TryGrid, you actually have a form that you can fill out, and you can put notes in there and say, I want to talk to somebody in the sales team or the support team more than the sales team, and they can help you go through some of that sizing in regards to that data. But it's a really good question. It just takes more questions to get to the answer, and the things that I would need to know are what is the resolution size of each one of those monitors, so on and so forth. And we probably don't have time to go into all of it back and forth around that, so I'd encourage you to reach out to the sales team to get more granular and use some of the tools that they have for that sizing.
Another question is around how do we analyze what could be potentially offloaded to the GPU on VM? For example, YouTube, web meetings, video conference, etc.
So the GPU profiler, so that tool that I just mentioned is a great tool for running even in a non-NVIDIA grid solution. So if you're trying to analyze your bare metal solution to like say, all right, what GPU utilization is going on to kind of equate that what you might need, the GPU profiler is a free tool that gives you that. Also, if you're looking into the paid solutions that you can even demo into, let me back up here and show you this. Just kind of leave it on the screen. We can stop right here. But if you look at the partner and ecosystems, Lakeside, great tool for doing assessments. And within those assessment tools, they have the ability to pull some of that data to help around that profiling and sizing as well.
Okay, and related question is this tools also available for K1 and K2 cards?
Yeah, these tools will pull some of that data. K1 and K2 don't have quite the expanded libraries that the Maxwell and ON have, and they won't evolve with additional features as Maxwell and ON will. But there is some capabilities within K1 and K2, specifically like the profile or the GPU profiler tool that will pull some of that data in.
Okay, and any integration with the Logic Monitor platform?
With which platform was it?
Logic Monitor.
I'm not sure if there is. If there's not integration, encourage them to reach out to us. We have a team that can work with them, make sure they get the right SDK, and we can help them get that integrated into the solution. We are not picky. We want to work with everybody in the ecosystem and get that out there. It's not hard to do. It's a simple SDK, and they can grab that data now. So if we're not working with them, we would love to, and we would be happy to help them get it integrated into the solution. That's also a really, really cool point, because almost all these vendors that you're seeing here, you heard Citrix, 2.5 months. Everybody's able to turn around this pretty quick because we've got a very well-documented SDK that gives them that capability. So have them reach out to us, and we'd be happy to connect them. My contacts should be available somewhere, and they can reach out to me, and I can pass them along.
The next question is about, is there any recipe guide for lining up the Citrix policies on XenServer or any GPU parameters for various applications? For example, Adobe Photoshop versus the other CAD applications. Can you spread some light on that?
We pull, so there's a couple answers there. A specific guide to each individual ISV relating to Citrix policies, that really does not exist. What does exist is details within the policies of what you should be implementing. We recommend to enable the high graphic, best experience kind of default policy, and then kind of tune down from there by default. When we get into ISV vendors, we have something within our driver called the ACE, or Application Configuration Engine. Now that ACE is a part of the solution as well, and that is a piece that can reach into the application and do some configurations there. So hopefully that's enough. But if there's more features you're looking for, hit our forum. We have grid forums. Post something, let us know, and we'll take the feedback. We love to take feedback, and we'll continue to evolve and make the solution better.
So what is the memory that's needed per VM to reach 4K resolution?
So 4K resolution is we can do it with a 1 gig profile. It needs to be a virtual workstation 1 gig profile. We can enable 4K functionality.
Cool. And how many license vApps grid do we need to buy for an app with 100 users?
100. Well, that depends because it's on a concurrent basis, right? So how many of those users? Oftentimes, if you look at NVIDIA's XenApp usage, we have almost 11,000 employees that are using, a couple hundred concurrent XenApp licenses. Just because not everybody's using it all the time. So the same model would apply with the NVIDIA Grid solution. What's your concurrency rate? Apply for the concurrency rate. We have a very similar overage, where there's a 10% overage kind of model in place that you get when you purchase it, and in case there is an overage, and you're good to go. But think of that on that kind of concurrency basis.
And similar to XenMotion being supported for NVIDIA vGPUs, will vMotion also be supported, since most of the XenApp and XenApp workloads run on Hyper-V?
Or VMware you're
sorry,
referring to?
ESX, sorry. So similar to XenMotion, yeah.
Unfortunately, that's kind of a tough question that I can't answer. I can't speak for VMware in regards to their release time frame and what they're working on. I would encourage you to reach out to your VMware team and ask that question. And this is, again, one of the reasons why it's important with our readiness relationship with NVIDIA, that I have a very similar one with VMware, where I would never breach any confidence in regards to what's being worked on. So please reach out to your VMware team to discuss VMware specific features.
So I believe when using GPU with vSphere, the feature vMotion is disabled by default as it's not supported. So the question is again, do you know when we can expect a patch release to support vCenter vMotion?
See, last answer. Yeah, I can't comment on I can't comment on VMware's roadmaps. I apologize.
Do you envisage? Yeah. So the next question is on. So listen, Kev, this on Titan GPU. So do you envisage grid technology ever being able to deliver the performance demanded by a high-end gaming user, for example? In other terms, will there ever be a solution where a Zen desktop server machine with grid can outperform or at least keep pace with the gaming machine with the latest GTX Titan GPU?
Yeah, I mean that's a good question, right? If you look at the same GP 102 or whatnot, that would be in a Titan, which I believe that I mentioned there. Those are extremely high-end, dedicated to a user. If we were to take that same type of a GPU and pass it through or use a one-to-one instance to it, we can probably get better performance than a gaming machine. There's other factors in play. If you look at kind of VDI type solutions, they're really not optimized for delivering games. And the reason being is that they need to deal with low latency business use cases, peripheral support, printer support. There's a lot of overhead in regards to the overall protocols, and this includes VMware's protocol and every other protocol that's out there. There's overhead that doesn't optimize them for a gaming experience. If you're looking for remoting gaming, I'd have to probably lead you to our GeForce Now solution, which we've optimized specifically for gaming, and we feel it's a better experience than that you would get from purchasing a card and running a gaming rig, and that's like a Netflix of that. Or the experience where you have an NVIDIA Shield TV and your gaming machine downstairs streaming from that machine downstairs to your TV. We can do that in 4K resolution nowadays at very high frame rates, perfect. But it's specifically optimized for gaming. So not necessarily the GPU as much as it is just the other overheads that deal with these kind of more business remoting protocols, if that's a decent answer.
And also, can you comment on the support for Hyper-V? Like what all is supported?
Yeah, so Hyper-V today supports, RemoteFX, if that was something that you chose. We typically don't recommend RemoteFX. RemoteFX, VMware's vSGA solution, are technologies that we classify as shim models or API intercept models. What this means is that they are writing the graphics driver that goes in the virtual machine. They're limited to DirectX and OpenGL versions. Then they look for that to happen. They intercept it and then kind of send it to the GPU on behalf of that virtual machine and then hand it back up. Extra latency. Overall, the solutions aren't great. Now, with Hyper-V, what does work and works really well is DDA. So using direct device pass-through type scenario where we just take the GPU and pass it into like a XenApp machine. That's what's happening in Azure today, and works phenomenally. So I would recommend for a really high-end user where they need the whole GPU, Hyper-V works fine. It's the trying to share the GPU. They're not leveraging NVIDIA's kind of virtualized GPU technology at this time, and so that's where kind of its weak point is today.
And Jared, can you also give some details about the Windows 2016 support GPUs?
Yeah, so Microsoft did some things better, some things worse with Windows 2016. Overall, Windows 2016 is much more efficient at leveraging the GPU. So there's a much better experience based on the same kind of Windows 10 core kernel. But Windows 2016 is all in all much better at leveraging the GPU. The latest version of Citrix XenApp with 2016 is the best XenApp experience graphically that they've ever produced. So we've got a lot of positive things happening out of there. Occasionally a few challenges that things are being worked on, but for the most part, it's been a really positive experience.
And how does grid impact overall power consumption of your hardware platform?
It increases it. I mean, if you look at, there's some intelligent things with the GPU. The GPU, if it's not in use, it can down throttle itself. But if you look at the overall power consumption of like an N60, you're looking at potentially a 250 to 300 watt board. So you're adding, potentially, a couple hundred. If everything's maxed on the GPU, and you had two M60s in there, you have the ability to add somewhere between 4 to 600 additional watts per server, which is GPU usage there. But don't take that as a hard number because there's a lot of intelligence in the GPU that will downclock. So that's technology that we've worked on pretty aggressively. The GPUs will throttle themselves back and won't fully consume all of that power all of the time. If you are currently a NVIDIA customer or you're looking for it, part of those tools that we have there show power consumption. So it's actually a number that can be reported on, which is kind of cool. So it gives you the ability to see how much power is being consumed. It very rarely hits those high-end numbers unless you're just beating the snot out of it. That's a pretty lower end number for the most part on average consumption.
So there's another question here. So we have like about 100 plus mobile users. Most of the time they are working on mobile network and latency can go up to 150 milliseconds. So from the latency reduction perspective, can NVIDIA GRID improve the WAN latency reduction? And if you could spread details on how does it do that?
Well, yeah, let's answer the question very carefully. No, we can't do anything about WAN latency. WAN latency is WAN latency, and that's a number, right? So I believe the number you said was 150 milliseconds. So if we take that 150 millisecond latency number currently, we're never going to be able to reduce that. That would take, maybe Citrix technology or other things to reduce that latency, or network things, better fiber optics, whatnot. But if you go back to this slide that I was showing down here in the Windows 10 section around like the real aspects of click to photon, with a remote kind of solution without a GPU, we can take that 150, basically add 220, and that's when I click to when I experience it. And that's not 100% accurate, by the way, so be somewhat careful there. We can reduce the overall latency quite significantly, around 40%, as long as the NV ink is being used.
Perfect. Yes, it does. So another on the vGPU. Can vGPU be used by virtual PC users for non-graphical usage? For example, that is like statistical analysis work.
Yeah, so there's a Bitcoin miner out there, or a Litecoin miner out there, I believe, is what is happening, and the answer is no. It can be done. We actually have users that do it, but it typically falls into the kind of virtual workstation play. So you get a virtual workstation license, and anytime you're doing any compute type workloads, kind of for off-screen, just sitting there doing work, I wouldn't recommend anything other than a full GPU. But we have people who have done it, right? So they have 4 virtual workstation licenses, 2 M60s. They get each virtual machine a virtual workstation license. They, run, in this case, a mining software of some way, shape, or form, and they let it run there and produce some form of crypto coin. It's being done. It's been done. It's probably not the most efficient way to do it. I know this model. I know this industry pretty well. But it could be done if you wanted it to, but it wouldn't be with a virtual PC user, and it wouldn't be with a carved-up version of a GPU. You do it with a full GPU. And again,
No, that's so. As this is going to the next question, which is on the EXI host outage and high availability feature. So in the XenDesktop VDI environment that is leveraging the Grid vGPU, will the HA feature just kick in and the XenDesktop connect to another vGPU on a functional host? Is that possible?
No. So I think what you're asking is if I'm just running a branded virtual machine, can I leverage a vGPU on another host? No, the virtual machine So that's an interesting question. There is the holy grail of what everybody wants is just to create a whole bunch of GPUs and have any virtual machine use them when they need them. I think is what they're asking. That can be done. We have technologies that can be done in, but it's very specific for like rendering. And we've got some rendering technologies that can do that type of stuff. But for average, everyday, productivity applications and/or graphical applications, each one of those virtual machines would need a virtual GPU assigned to it. It really comes down to bandwidth. There's just not enough bandwidth. If you look at the PCI bus between CPU, memory, PCI bus, GPU. We need those all really close together for optimal experience, and going over a network to get to leverage a GPU somewhere else, it's just latency is too high, and it wouldn't work. If we were to create a scheduler and distribute a job for like rendering, then there's aspects of it that can't work. But I think that's what you're asking. If I'm not, maybe you'll have to clarify the question.
Yeah, so he has just followed up. So can we just disable HA and DRS on a vGPU workload? If you can just take that.
What pieces does he want to disable?
We have the HA and DRS. So that's
yeah.
IoT.
Okay, you're talking about high availability type features, ZenMotion, having DRS, HA, and that those can't be, the virtual machines and GPUs cannot be a part of those basically resource distribution and recovery. So a couple things. DRS is not supported in regards, and maybe an aspect of it is around kind of placement. When virtual machines come up, it'll kind of distribute evenly across hosts. HA is supported. So if you actually are using a vGPU and you fail a host, you're going to lose the VM, but it will restart on existing surviving hosts. So HA is supported today with both Citrix and VMware in regards to ESX and XenServer. So high availability is fine. DRS having come in and proactively try to motion machines around, that is not supported because you can't motion the machines. But high availability is supported.
Okay, so we can keep the HA enabled, and that will just work out if the one ESXi host gets.
Yeah, when you configure, I have a video, I believe, out on the NVIDIA YouTube channel that I put together around this, by the way. So you maybe track that down. But you have to enable HA, and then within the DRS settings, you have to disable proactive DRS or proactive HA and some of those additional features. But there's a YouTube video I have out there that I made for this.
Got it. And so the last question that we have for today's call is, can you discuss grid licensing for the education sector? I think this comes often. Which licensing model would you recommend?
Yeah, that's fantastic. Super awesome question. So we just released a new model. It's really simple. There is one license for everything education. Technically, kind of two. If you were going a XenApp only route, there's a much lower license cost. But we've now taken all of the virtual workstation, virtual PC. It's a no thought process anymore. You don't have to pick and choose. It's one license. It's Grid for EDU. It's $99 and you're done. And then you've got support, maintenance, everything on that, and you own it perpetually. If you replace your servers in 3 years and put new Tesla cards in, those licenses will work with that too. So we've simplified it. It's called Grid for EDU. Talk to any of your NVIDIA teams, and they can help get you the right licensing in that regards. But there's, I believe it's actually a non-profit and EDU that pricing falls under. I could be wrong about the non-profit, so double check with your NVIDIA team around that. But I'm pretty sure that it's. I know it's Grid for EDU, but I don't know if we have extended it to nonprofits, but I believe we were going to or did.
That's it. Thank you. And the last question is about the downloading the management SDK, and I think we shared the link on the chat itself. So, and
yeah, the
other
management SDK, it's actually developer.nvidia.com. Really simple. There's a whole bunch of other stuff there that's probably a little bit confusing, but to take a look at it, there's all different kinds of great technology. you're interested in machine learning and artificial intelligence and all that stuff's out there too, and we'd love to see you participate in all those communities. But thank you so much for letting us join the the readiness call here. The ready team is just awesome, and appreciate all your guys' willingness to have us and have great attendance as usual. So thank you from all of us at NVIDIA for joining today, guys.
Hey, thanks, Jared, and thanks for the audience here for attending our webinar. It has been a full-packed webinar today, and that's it from our broadcast. And one last question that kept coming is about the slides and the recording. Yes, we will be sending it over to you on an email in a day or two. So wait for that. And for a couple of more follow-up questions that some of the attendees here asked, yes, we'll be following up with you shortly. So thank you everyone, and this shall conclude our broadcast.